Bismillahirrahmanirrahim. In this video, I will solve an ANOVA analysis of variance problem by hand. So basically, ANOVA is used to identify or analyze the effect of different treatment levels. Just like you can see it there, we have four treatment level of the hardwood concentration 5, 10, 15, 20, and we want to analyze their effect on the tensile strength. Let's go to the problem statement. A manufacturer of the paper grocery bag is interested in improving the tensile strength of the product. So tensile strength is our response variable. Product engineering thinks that the tensile strength, that the response variable, is a function of hardwood concentration. Means when the concentration of the hardwood changes, the tensile strength varies in the pulp, and that the range of the concentration of the practical interest is between 5 and 20%. So that's why. So industry divided this 5 to 20% into four levels. These four levels of the hardwood concentration are 5%, 10%, 15% and 20%. They decided to make up 6 test specimens. These are the replications using a pilot plant. All the 24 specimens, it means that 24 experiments have been performed in a laboratory on a tensile tester. The tensile test is a universal testing machine in a random order. In order to avoid the biasness, they have performed the experiment in the random order. So while using the 5% hardwood concentration, they have performed 6 experiments and they got the value 7, 8, 15, 11, 9 and 10. Likewise, they have performed 24 total experiments. So now we'll discuss the level of the factor. There are 4 levels of the factor and we call it treatments in the design of experiment technically. These are 5, 10, 15 and 20. Then each treatment has 6 observation or replication or replicates. So these are 1, 2, 3, 4, 5 and 6. These are 6 replications. The runs experiment are run in the random order to avoid the biasness. The outcome of the experiment that has been measured or we are interested in is the tensile strength, and that is our response variable. To solve the problem, we have to use these two formulas. The formulas are sum of square of the treatment and sum of square of the total. This T means total. Now what's the formula? We start from the simplest one. This N, it means that the overall data points. We have total 24 observations. We can write here 24 and 24 here. Then we will talk about this Yij. These are the individual observations. Individual observation means in our case we can say this 7, 8, 15, 11 till this 20. These are all individual observations and we represent them by Yij. Then the second thing is Y dot dot. This Y dot dot means overall sum or grand sum. You can see it here. This 383, this is equal to Y dot dot. This is the grand sum of all of the observations. Then the next thing in the formula is so as you people know that we use I for the rows. So we have total 4 treatments and 4 rows, and here the formula is written Yi dot. So dot means the sum and I means the rows. So we have 4 rows. In short, this depicts that we have to use the sum of the rows. So I have taken the sum. We have the sum 60, 94, 102 and 127. We can write them like I dot, 1 dot, 2 dot, then 3 dot and then 4 dot. 4 dot means it's the sum of the 4th row, means from 19 till the 20. Why we are doing these calculations? Because we have to make this ANOVA table. In this ANOVA table, we have this sum of square of the treatment we will get from this formula. Then we have total. This is basically SS total, sum of square of the total, and we will get it from this formula. One thing remaining, error. This is sum of square of the error. So sum of the square of the error, it can be computed using this expression. So when we have sum of square of total and when we have sum of square of the treatment, we can easily find the sum of square of the error. So now after that, the next thing is degrees of the freedom. So degree of freedom, the first one with the treatment. What's the degree of freedom of the treatment? It's A minus 1. We represent A with the levels of the factor, means treatment. There are 4 treatments, so 4 minus 1, there will be 3, it becomes 3. Then we have 4 treatment level, n mean the number of replications. So 6 minus 1 5, 5 multiplied by 4 it becomes 20, and the total is always 1 less than the total number of observation. It means 23. However, if we compute it, so how we can do it? 4 number of levels or number of treatments, 6 is the number of replication. It will be equal to 24 minus 1. This will be equal to 23. Then we'll talk about the MS treatment and MS error after the calculation. So first of all, we will compute sum of square of the total. Here is the formula of the sum of square total. Yij, these are the individual observations. We will take the square of all from 7 square plus 8 square. Now this is the technical way of writing in the assignment or quizzes or in the exam or in the research paper as well, that if we are doing basically summation, so there will be obviously the sign of the plus in between all of these terms. So if the expression is too lengthy, then what you will do, you will write only the first two and the last one, then you will write the operator, means the plus sign, then do not write all of them. Instead of that, insert these 3 dots. This is the standard way of writing the expression. Then this minus sign. After that, I told you that 383 is the sum of all of the observation, and then the square is there, and then n is the 24 observation we have. So during the calculation we will get 5.2.96. 512.96 is the sum of square of total. Then sum of square of the treatment. So y I dot, it's the sum of the rows. We have 4, then these are the sums are 60, 94, 102 and 127. So these are the sums. Then n, basically this n is the number of replications or how many replication we have performed. So these are the 6 replication for each treatment. Then this sign of the subtraction minus y dot dot whole square. Again, this is the sum of all of the observation, then square, and this n, this is the overall sum we have. Upon the calculation, we got sum of square of the treatment equal to 382.79. So when we subtract 382.79 from 512.96, we got 130.17. This is our sum of square of the error. These are the calculations that we have to perform in ANOVA. Now the last and the most important thing is the ANOVA table. So in order to make the ANOVA table, first of all, list on all of the calculations that we have performed, sum of square of the treatments, then error, then total. I told you how to calculate the degrees of the freedom. Once you have done with that, now we will come toward MS or mean square. In order to compute the mean square for the treatment here means hardwood concentration. So what you will do, you will divide the sum of square of the total. Let me write sum of square of the treatment divided by degree of freedom of the treatment. It will give you mean square MS treatment. Okay, so it means that whenever you divide 382.79 by 3, you will get 127.6. This is the MS treatment or MS hardwood concentration. Likewise, the second thing we need is the MS error. How we will use the same formula, that 130.17 divided by 20, we got 6.17, and we'll use again the same formula. Now what's the F? Basically F test is the ratio of two variances. So mean square of the treatment, this is one of the variance between different groups, and this MS error, this is basically the variance within all of the treatment. So whenever we divide these two variances, I mean F naught is the formula of F naught is MS treatment divided by MS error. What you will get? You will get F naught value. So when you divide 127.6 divided by 6.51, you will get the value of 19.6. And then the last thing, how you will compute the p-value. So you can compute this p-value either using the Excel or any software. So now the last thing, how you will take the conclusion of whether we have to reject the null hypothesis or retain the null hypothesis. So we have the criteria. I'm going to write down if F naught value is greater than the F tabulated value. F tabulated value is F f alpha comma and 1 minus 1 is the degree of freedom of the numerator, means degree of freedom of the associated with the ms treatment, divided by n2 minus 1 degree of freedom of the denominator, or degree of freedom that is associated with the ms error. So here we took over alpha value equal to 0.05. The degree of freedom of the numerator or treatment is 3. We have written there. The degree of freedom associated with the error is 20, and we got written there. Now, how we will get this value? This is basically the f distribution value or f tabulate value. We got here 4.94. How we will get this value? You can get it from the internet, or you can get it from the appendix of your book. Let me tell you how. So here the book has taken, or the notes had taken 0.01. However, I have written 0.05. So let's go to the table of 0.05 first. We have this table of 0.05f, then we have this v1, this is the degree of freedom of the numerator, v2 degree of freedom of the denominator. So we have 3 for the numerator and 20 for the denominator, so we got 3.10 as the value of the f distribution table value. I will also tell you about f 0.1 value. So you people can see it here, f 0.01 and then 3 and then here 20. This is equal to 4.94. I am going to highlight it so that it will be easy for you. So this is the f table value. Now if we go again towards the presentation, so we will see that over a value that we have computed from the question, that f naught value, this f naught value, it is greater than the f table value. I mean that 19.6, this is greater than 4.94 if we take the alpha value equal to 0.10, or it is also greater than 19.6, also greater than, I think we got the three value, the value of the table from the table for 0.05, that was I think 3.9 if I'm not wrong. Again, it's the large, this is true, so we reject the null hypothesis. It means that there is a statistically significant difference exists among the 4 treatment levels on the response variable, and then in such a case the hypothesis that we have formulated for our study, we will reject over this H naught null hypothesis, and our alternate hypothesis will remain that there is significant difference exist among the means of 4 treatments. Thanks a lot for watching the video. Bye.